Okay, so this is phases of matter. Okay, this is all about properties of materials and so on, and how they interact with heat and temperature, and also um, the properties of matter themselves. So what we're going to look at is density. We use density because, I mean, if you talked about heavier all the time, it's not always true because we are disregarding the size of things. Density takes in the size and mass of an object. So when you look at density of something like lead, then it's always a constant. It doesn't change. But the mass of a lead changes depending on its volume. So that's why we use density. What's the definition? Well, it's the ratio of mass to volume. Of any given substance. Okay, so essentially that's what it actually means. Okay, it's the mass to volume ratio and doesn't change. Let's say, for example, actually we've got an example on the next page. We'll have a look at it there. It is not just how much mass stuff there is inside a certain volume. That is moles. Okay, so do not mistake density with moles. Is it scalar or vector? Well, of course it's scalar. It doesn't matter which way you're looking at it. Oh, wrong way, sorry. Okay, the ratio stays the same in each case. So if you had 1,000 kgs of water, it would have a volume of 1 meter cubed. So a ratio of 1,000 to 1 or 1,000. Now say you had 500 kg of water, 500 kgs of water, the volume would be, well, it's going to be 0.5 meters cubed. We've halved it, so we're going to keep the same ratio. So that's 500 to a half, which is the same as 1,000 to 1. Okay. Now say again that you had 6 meters cubed of water, what would the mass be? We're going to have the same ratio. If it's going to be something to 6, it must be 6,000 kgs. Now if you had a uniform piece of wood of density 924 kgs per meter cubed, what would the density of each piece be if it was cut in half? Well, if you cut it in half, so here's our piece of wood. If we cut it in half, well, effectively you're halving the volume, but then you're also halving the mass, so the density stays the same. Oops. Density is the same. Formula for density, so rho is a symbol, mass divided by volume. Unit for density, drive the unit for density using the formula. Well, the formula is rho equals m over v. So what's the base unit for mass? It's kgs. Base unit for volume is going to be meters cubed. So it's kg per meter cubed. Actually, sometimes things are expressed in grams per centimeter cubed because that's usually a smaller number, so that's quite often used. The next thing we look at is Brownian motion. Now, Brownian motion is talking about how particles behave, especially the ones we don't see. 3 videos here, and the 2 of them are actual videos of Brownian motion. You actually see the particle movement, and one is a model trying to represent it. Now, if we're explaining it, we need to look at 3 different parts. Okay, we're going to look at the experimental setup, the observations, and the conclusions drawn. So let's look at the setup. Now, the actual thing is, well, let's do one with smoke. Okay, so what we're going to do is going to have a little cell. Okay, so that is a cell. Then inside that, we'll put a smoke particle. And then we're going to put some light below it. Okay, so there's light. and then above that you then have a microscope. Okay, so that is the setup.